All right, let's apply Kirchhoff's laws to this circuit to solve for the current passing through the various resistors. The first step is to assign the direction of current. Let's choose current I1 to flow in this direction, current I2 to be flowing in this direction, and current I3 to be flowing in this direction. Now the choice of current's direction is completely arbitrary. You're free to choose accordingly. And the next step is to recognize that current flows from higher potential to lower potential for the resistors. Label that plus and minus accordingly. Same time, recognize that the positive terminals of the battery at high potential, negative terminals at a lower potential. Then we're ready to apply our loops, right? So let's choose this as our first loop, loop 1. Recognize that the total change in potential as we go around the loop will be equals to 0. So we start from here. We're going from minus to plus. That's an increase. 3, 4. Minus to plus, it's an increase. 2, I2. Plus to minus, it's a decrease. Total change in potential equals to 0. 12, 2I2 minus 20 plus 20. So I2 is equals to 4 amperes. Next, we recognize that at this terminal over here, or at this junction over here, I3 plus I2 must be equals to 3 amperes. So we have that I3 plus I2 equals to 3 amperes. Since we solved earlier for I2, which equals to 4 amperes, therefore I3 is equals to minus 1 ampere. Now the minus sign here just indicates that our initial choice of direction for I3 is incorrect, right? So we just have to recognize that the direction of I3 is actually from the right to the left. We can next consider a second loop over here. Let's call that loop 2. Again, as we go around the loop, right, when you go from plus to minus, that's a decrease in potential. Plus to minus is a decrease in potential. Minus to plus is an increase in potential. Total change in potential equals to 0. We solved earlier that I2 is equals to 4. And I3 is equals to minus 1 ampere. Right. So therefore, I1 is equals to minus 8 minus 3, which is equals to minus 11 amperes. So again, the minus sign here just indicates that our initial choice of current for I1 direction is incorrect. And instead of flowing from left to right, the direction of current for I1 is actually flowing from right to left. Now to solve for V, let's consider our third loop, loop 3. We again recognize as we go around in this loop, the total change in potential equals to 0. Minus to plus is an increase. Plus to minus is a decrease in potential. Plus to minus is a decrease in potential. And the total change in potential equals to 0. Right? So we can solve earlier for I3, it's given as minus 1. So V minus 3 minus 1 minus 12 equals 0. Therefore, V is equals to 9 volts.